So we're still in the white packet. We'll continue on with our studyages of vectors. Remember that a vector is now that we're done conversing with each other, we can talk again about a vector. A vector represents a unit in math that has both magnitude and direction. The magnitude of a vector is what from yesterday? The length of the vector? Yep. And how do we find that? Given the component form of a vector. We're already given the component form, right? Component form is one in the funky brackets. Nope. Square the horizontal component, square the vertical component, add them together, take the square root. Okay? You had said it's right triangle trick, or right triangle Pythagorean theorem-ish type stuff. Yep, it's right triangle Pythagorean theorem. Yep. Direction. We've been talking a lot of direction stuff lately. Okay? So direction then of a vector. What are we going off of? Are we going off of bearing, navigation, math, or reference? We're going off of math. Okay? So in order to find that, then we got to find reference angles and then adjust it for the quadrants. Okay? So we're unit circle angling for the directions and all that fun stuff. Okay? All right. So we ended with number 8 yesterday, which is a great place to pick up today. So vector V is -3, -4. I want you to find me the magnitude of V and the direction angle of V. Side note, you will probably need a calculator for the direction angle. Go. So first off, we can find the magnitude of V by squaring the horizontal component, squaring the vertical component, adding them together, and taking the square root. Okay? So 3 squared is going to be 9, 4 squared is going to be 16. So then we have 9 plus 16, which is the square root of 25. So the magnitude of V is 5 units. Okay? We are not in quadrant number 1, so therefore it's a theta prime, it's a reference angle. That's going to be the inverse tangent of 4/3. We're going to drop both negatives on that one. Inverse tangent 4 divided by 3. There we go. Inverse tangent 4 divided by 3 gives me 53.13 degrees. This vector happens to fall in quadrant number 3. So my actual theta then is going to be 180 degrees plus my reference angle. So that's going to be 233.13 degrees. Agreed? Questions, comments, concerns, clarification? All right. Next topic that we have to talk about is unit vectors. A unit vector is a vector that has a magnitude of 1. Okay? So what we can do, we have two. Actually, let me Tabitha breaks. Let's go back to this vector. If I wanted to make this vector into a unit vector, okay? So if I wanted to transform vector v into a unit vector, well, my magnitude would be 1. So we'll call it v. We'll call it u. We'll make it v vector u. Okay? So vector u then would have a component form of 1, because that's the magnitude of that vector, times the cosine of v's direction angle, comma 1 times the sine of v's direction angle. Okay? So if I did the sine, we do the cosine first. If I do the cosine of my answer, I would get here negative 0.6 for the cosine of that, and the sine is negative 0.8. Unit vectors have a length of 1, so their magnitude is 1. Okay? So yesterday, in number 7, if you look right above this one, or left or somewhere, wherever number 7 is, we talked about how that any vector could be written in component form as the magnitude times the cosine of the direction angle, magnitude times the sine of the direction. Remember that? Written on your paper? Right by number 7. Okay? 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 So if I want to make v into a unit vector, it's got to have the same direction, but it can only have a length of 1. Currently, the length is 5. With me? Okay. So we have to make it smaller, so that's a unit vector, but in the same direction. So we take the magnitude times the cosine of its direction angle. So I did this calculation, and I got this. Okay. Did this calculation, and I got that. To a unit vector. And that 0.6 squared is 0.36, 0.8 squared is 0.64, 0.36 plus 0.64 is 1, square root of 1 is 1, so that vector has a length of 1. Okay. All right. Now, there are two special unit vectors out there. The first one is called I. It is the unit vector 1, 0. And the second special unit vector is j. It is 0, 1. And what those two unit vectors do for us is they allow us to, let me get the proper terminology. I want to say it's linear combination, but yep, it is linear combination. Okay. No, so vector written as a linear combination of I and j. So we can write any vector as a linear combination of I and j simply by saying vector v is the vector -3, -4. Well, that's going to be -3 times the vector I minus 4 times the vector j. So this would just be it's I and j form of a vector. Okay? So you have the component form of a vector. The horizontal component is I, the vertical component is j. Write it up. Then that way you don't have to worry about brackets or you changing your brackets to parentheses or anything like that. What's up?
This is just a general question, but like where would we use the vectors?
We're doing the groundwork so that tomorrow we can get to all of the applications.
Okay.
Yeah. We just gotta lay the groundwork of the map, and then you'll see it over the course of tomorrow, Friday's video, next week Wednesday, and next week Thursday. All the different spots where this can be applied. It's just another way of writing it.
So if you had like another
Give me another random vector.
1,
1, 2. Okay. So if you have vector 1, 2 in I and j form, that would be I plus 2j.
because the 1 is just 1, and then 2 times j is just 2. Oh,
Give me another vector. Somebody else give me another vector.
6, 8.
6, 8.
It's just like another way of writing it. So it would just be 6i equals 2j. Yeah, that's not complicated, but like what is the
They're both special unit vectors. So they're vectors that are length 1 that we can then write it as a unit vector.
So basically you're just adding variables.
It's made up apparently.
It is.
It means nothing.
No, it's made up. You just add letters to numbers.
Because mathematicians, well, yes, 1, and 2, the funky brackets that we got going on look a heck of a lot like parentheses, but parentheses mean something different than the funky brackets. So mathematicians got together and said, let's make it without any kind of symbolization like that. We'll just put letters in.
What if I squared or I is cubed?
Can't.
I think I is always
I is always I. J is always J.
So it's
Yeah.
just an easier, it's just a different way of writing of what a vector really is.
Yep.
You don't need parentheses or anything. I kind of like the I.
Yep. Yep.
That is so.
Yep. Yep. Okay? All right. So, in general, okay? So if I have a vector v that it has a component form of x comma y, then I can find the magnitude of v by taking the square root of x squared plus y squared. I can find the reference angle for my direction angle by taking the inverse tangent of y over x, but I have to remember to drop my negative sign. Then, My actual theta is my reference angle in quadrant 1. My actual theta is 180 degrees minus my reference angle if I'm in quadrant 2. My actual theta is 180 degrees plus my reference angle in quadrant 3. And my actual theta is 360 minus my reference angle in quadrant 4. Okay. If I have those two already, I can find the x part of my component form by taking the magnitude times the cosine of the direction angle. And my y then would be the magnitude times the sine of the direction angle. X is the horizontal component, y is the vertical component, magnitude is the length of the vector, and obviously the direction that it's heading. Okay? Let's try number 9. Number 9 says, if the magnitude of u is 2, and u has a direction angle of 30 degrees, and the magnitude of v is 3, and has a direction angle of 90 degrees, we need to find u plus v in component form. We need to find the magnitude of u plus v, and we want to find the direction angle of u plus v. It could be. It could be. We can do this one in INJ form if we want.
Can you do both ways?
Sure. Super easy to do. Okay? So what's the first thing that you think we should do in this problem? Not quite yet. I mean, we can, but we don't need to. If I want to find vector u plus vector v. So is the resulting going to be 5?
Yeah, but not 5.
That's what you gave us. Actually, let's not do that. What do you think? We don't have any sides yet. We don't have it yet. We don't have SOHCAHTOA.
Can we find the other angle?
We don't have any angles.
Can't we just write 2 comma?
They didn't pick up on it. U plus v is 5. Done. Moving on. Right? It's 5, right? Okay. But isn't a vector have 2 parts to it? It's got an x and a y. A horizontal and a vertical. 5, 5. Moving on. Done. Okay. Direction angle is 45 degrees. Magnitude is 5 square roots of 2. Done? All done? Gosh, you could. I mean, it's not really going to help us yet.
I vote you show.
I vote you guys already know how to do this. So we should find what vector u and vector v is first, right? Because if we're going to add them together, we should probably know what they are first, right? Okay, so let's start with vector u. What's vector u? Okay, what's up? find vectors and component form first. And see, remember that slide that I just gave you? Remember this slide? Remember this one? Where I gave you all of the answers for everything in this unit on this one slide? Yeah. Remember when I said if we don't have x and y, what we do is we take the magnitude times the cosine of the direction angle? Remember that? Because it was like all of maybe 4 minutes ago. Okay? Cosine at 30 degrees. I mean, exact. You should know this. It's on the unit circle.
3 over 2.
Square root of 3 over 2. Square root of 3 over 2 times 2.
Square root of 3.
Square root of 3. Sine at 30 degrees. 1/2 times 2. 1. So the component form of vector u is the square root of 3 comma 1. Okay? Now what do we need to find? We need to find vector v.
Do you always have to do cosine and sine to find both things? I'm going to say yes.
Well, cosine for x,
Well, yeah.
sine for y.
But if you have like one of them, you have like a y, and you have an x, and you just do cosine.
It all depends. Meaning, this one, maybe, but I'll tell you why after we find it first. Okay? Right? But I want to find it first. So what is it?
Oh, not 30, 90.
Since we're on v, that's why we switched to 3. Okay? Alright? What do we got? Which one? Cosine of 90 is? So 3 times 0 is?
And then the next is 0. 0, 3.
Sine of 90 is 1 times 3 is 3. Okay, Madison, back to your, do we have to do sines and cosines of them? Yes, if it's not 90, 180, 270, or 0. Okay? Because so 90 is straight up. So it's just going to be 0, comma, whatever the magnitude is. 180 is straight out, so it's going to be negative magnitude, comma, 0. 270 is straight down, so it's going to be 0, comma, negative magnitude. And 0 is straight out, so it's just going to be magnitude, comma, 0. Otherwise, yes, you got to do magnitude, cosine, magnitude, sine for each one. Okay. Okay? So, I want to find vector u plus vector v in component form. So I add these two columns, right? So what is vector u plus vector v in component form? Square root of 3 comma 4. Now, find me the magnitude, find me its direction angle. Now that you have it, now you can do your calculation. Tell me if it's 5 or not.
For C.
For C, 2. Great.
Because the square
So my magnitude is going to be the square root of 3 squared plus 4 squared, and then take the square root of that. So that's going to be 3 plus 16, which is going to be the square root of 19. So the magnitude of u plus v is the square root of 19. Agree with that one?
Yeah.
Okay. My direction angle is going to be, whoops. I get 66.59 degrees. Since it's in quadrant number 1, my reference angle is my actual angle. So theta of u plus v is 66.59 degrees. Questions, comments, concerns, clarifications? With that being said, I would like you to now do number 10. Round your vector to the tenths. Let's go two. We'll go 2 places. Go 2 places. Go 2 for everything. Yes?
Yes.
I got 58.48. Yes? correction angle of 83.4. Yes? Okay. I'm giving you a mod to continue your work on your homework packet.